Today I wanted to share my modest experience with Kotlin Multiplatform, as that's the technology I chose for the project. My talk will be fairly short. After a brief introduction into the technology, what Kotlin Multiplatform is about, I will show you the project demo just very briefly so that you get a gist of what it is. And then I will talk about some challenges with KMP. There's a terrible echo. I hope it doesn't disturb you as much as it does disturb me, but if you're okay with it, I'll carry on. And in the end, there will be a Q&A session. So yeah, let's get started. All right, so I think the obvious question is, what actually is Kotlin Multiplatform, especially for those who don't deal with that, or maybe first time you're hearing about it. Does anybody actually use Kotlin Multiplatform here? Like for hobby project or in production? Okay, cool. Okay. So obviously I couldn't help, but it's not entirely new concept. It's that thing with write once and run everywhere, which is obviously something that Java has been trying to achieve for a long time and was quite successful. But in this talk, I just wanted to touch upon some similarities, but also differences, where Kotlin Multiplatform differs from Java and so on. So obviously that write once means write your everything in Kotlin, like Swiss Army knife tool, where you basically code everything in Kotlin, and then you're able to compile that Kotlin code into JVM or into native libraries, binaries on desktop or mobile applications without involving the JVM, or even you can also compile it to JavaScript or TypeScript and run it in the web browser. And obviously, it also covers a wide range of operating systems and platforms. So Kotlin Multiplatform is based on a feature called cross-compilation, where in Kotlin now you're able to not only compile code for JVM, but also using the low-level virtual machine, you can actually tap into that and produce those binaries and JavaScript. All right, so there's some obvious benefits with it. So I was trying to understand the major wins, if there's more to it but productivity, but it seems that productivity is indeed the major thing or major benefit. Obviously, writing everything in Kotlin and then producing native binaries, that reduces the effort your development team has to make, so you're potentially saving time and effort. But also, Kotlin Multiplatform tries to deliver the promise to retain benefits of native programming, meaning performance needs to be good, user experience, acceptable, tooling around that, etc. And since its inception in 2018 until now, it has gone far. Initially, 2018, 2019, or 2020, it was receiving some terrible reviews in terms of performance and capabilities, but that started to change slowly, which I will show on a brief example later on. So these are just these benefits again, just summarized. They basically fall into two categories. One is reducing the human effort, and the other one is like maximizing on machine performance. And I think this slide is slightly biased. I just stole it from somewhere, and there are always this credit slide, so you can check where I stole it from. But basically, it tries to say that Kotlin Multiplatform has a potential. It potentially ticks all the boxes. Potentially, it saves you time and effort, but also delivers acceptable outcome. If you go with the native approach, obviously you maximize on the outcome, but then it's going to cost you. You need specialists in your team. You need native developers. Code is not reusable. You have to rewrite the business logic implement it in a different language, so that all costs time and effort. I was further checking what people say in 2024 about the technology, and there seems to be agreement in the development community that it has improved. faster build times, smaller package sizes, and acceptable performance. So I picked a particular example just to prove that there is a potential. There are several examples I found. None of them, not all of them speak favorably about KMP, but this one was kind of close to my heart for a number of reasons. Reason number one, it's a repeated experiment. So author of the article actually did an experiment back in 2019, and back then it made sense for him to use Java and GraalVM. And now, 5 years later, he's still continuing on the same project. He re-evaluated and chose KMP for specific reasons. The second reason I chose this, that it's a typical network-intensive project, which I think is typical of many projects these days. So you make an extensive number of HTTP calls. And then, lastly, there was some overlap with the project I've been working on. So selfishly, I chose that as an inspiration. All right, here are the results. So the results are, the test was, that it let the tool generate HTTP requests for a certain amount of time, and then it captured the mean response time in milliseconds. And the point here is not that Kotlin beats Java tenfold. I think that's really not the point. But it just, again, goes to show that there possibly is some sort of a potential in using Kotlin Multiplatform, because in this particular case, it wasn't too shy of the results that were produced with Rust and Go, which are obviously much more performant overall. All right, and now I've been talking about Java for a bit and comparing it, and then the obvious question is, would multi-platform work with Java? And I owe Java a lot, a significant chunk of my career, and I think it has done a great job, and I think absolutely it does, right, through JVM. So if you look at the platforms on the desktop, we can say that Java is multi-platform thanks to JVM because it's so widely adopted. But if we move on to, say, mobile, then Android, yes, there is still Java, but superseded by Kotlin, but never mind. Let's say Java can natively run on Android or runs natively on Android, but then iOS, there is no Java. You would need tools that would, generate Swift or Objective-C from Java code. And there are tools like that, but then you need to play with different technologies and use different programming languages. So it's not multi-platform in the same sense as use a single programming language. And on the web, with the basically disappearance of Java applets in browsers, I think Java has established as a technology that supports web on the back end, but it needs to be accompanied by a front end that's typically JavaScript or TypeScript. So that's different skill set, two different positions, front-enders, back-enders, different technologies. So it's not multi-platform on the web. And then if we look a little bit under the hood, still very high level, but here we can see also why. Kotlin is a newer language. They have had a chance to work on the cross-compilation. So Kotlin now is not just a generic purpose language, programming language. There's also Kotlin native. There's also Kotlin for JavaScript. And with that, there comes a whole ecosystem of supporting communication with low-level APIs. There are modules or even UI frameworks that step into the whole multi-platform concept. Whereas what Java has, it has JVM, and then it has a reliance on third-party tools like GraalVM, which can achieve a similar effect. But obviously, Kotlin being the more modern language, it had a chance to learn from the past. So that's, I think, where the major difference is the cross-compilation capability that's not available in Java. All right, so now briefly talking about the project. It's a Zoom, it's a terminal application. It's two things, essentially. It's a Zoom, it simplifies communication with Zoom. It was born out of my frustration with Zoom unwieldy APIs. Initially, I wanted to just write an SDK around that and abstract away some confusing details. But then I was also looking for an application that would prove that the SDK is of any value. So I ended up writing command line utility that enables you to interact with Zoom and uses the SDK under the hood. Obviously, there is this QR code that leads to the repository, and your feedback is welcome, and your contribution even more so. So let me just quickly demo what the project does and how it looks like. Yeah, it's a simple command line application. I call it Zoom CLI. And then this runs natively as a native app on desktop, on Mac OS, and also Linux. As you can see here, these are now binaries, either debug executables, which are not optimized, that allow for debugging, and then these are optimized for production use. So I'm using the macOS version now, obviously, and then the tool has a bunch suggestions, so I can always easily arrive at commands I want to run. And the very first command I want to run is the login command, so that I can actually log into Zoom and interact with it. So in this case, I choose to sign in using Google SSO. And once this authentication is done, I can just go back to the command line. And now I can say, list my meetings. There is currently only one scheduled. Or I can just ask Zoom, who am I to Zoom? And I get my user details. I think that pretty much captures the gist of it, so I can just exit now. So yeah, that's just briefly about the project. Nothing huge. There'll be more commands in the future. Hopefully it's useful to somebody else. All right, going back to my presentation. All right, I talked quite a bit about benefits and how awesome it is, but obviously it can be a patchy road sometimes, and not everything goes well. So I picked 3 challenges I have had when learning Kotlin Multiplatform, and I would like to share them with you. So first challenge is what I would call mental shift, when it's no longer about just JVM and Java interop. Now with KMP, with Kotlin Multiplatform, if you start working with it and eventually you will end up with production code, then your responsibilities will grow, even to domains you don't know so well. So you will generate from your Kotlin code base, you will generate native binaries, and there will be production issues. The technology is still new. There'll be unanswered questions, and you're responsible for it as a developer. So these 2 examples here are from this very project I just demonstrated. On the very left, there is this native code I had to write. I'll get back to it a bit later. So basically, there is an overlap between JVM and LLVM. It's a fine line, it's an interface, and you need to be cautious of certain things, for instance, memory management. And on the right, so I decided to port my SDK to JavaScript so that I could run it in Node.js, for instance. And compiling Kotlin to JavaScript is one thing, but I got a ton of warnings. The package is too big, etc., etc. So optimizing it, that's a whole different story. And you need to understand something a little bit more about JavaScript as well. And then this one is even more obvious, and I think you will run into it quite early, which is compatibility issues. Because multi-platform doesn't necessarily mean that you will find a library that's suitable for the platform you are targeting in your project. So this QR code and link leads to a very useful project. I recommend checking it out. It has the ambition to enumerate all Kotlin multi-platform libraries there are and categorizes them. And as you can see, it's a mixed bag. Some of them support a range of platforms, but others not so much. And in my example, to give you a specific example, I personally like Ktor, and I also use it in my CLI project. And when I showed you the commands in the shell, what you did not see is that in the background there is a web server running that finalizes the OAuth flow with Zoom and then allows me to authenticate. But what I was not initially aware of is that while Ktor client can be compiled into JavaScript, the Ktor server is designed for JVM mainly, for JVM and native, but not for JavaScript. So if I decided to port my CLI into JavaScript for whatever reason and wanted to run it in a browser, some technologies or some companies do that. They have these browser shells you can open and play with them. Then I would have to either rethink the design, would have to call an external server somewhere else, or would have to swap out Ktor for a different library, which is something actually I'm considering to do. But the point is that with this being a new technology, it might happen that you will actually run out of options and will have to pivot and change your design or write something by yourself. So actually that productivity, it's not always guaranteed that you will be more productive. Sometimes it's going to be frustrating as well. And lastly, we just heard Gradle and the dangers of Gradle multiplatform, which is I'm exactly using the wrong approach, the one I should not be using. And I'm actually in the shoes of this dude who said, I have a complex multi-module Kotlin multi-platform project. Like, good luck. If you don't like Gradle, or if you're not proficient with it, you're not going to enjoy Kotlin multi-platform. I think I'm quite proficient with Kotlin Gradle multi-module, doesn't bother me. But with multi-platform, you have to factor in all these additional source sets you are going to maintain. So obviously, there is this premise of having a common source code, which is platform independent, and that you can nicely reuse on your platform-specific targets. But then also mind you that these platform-specific targets, they don't need to be just generic native. They can also be very specific native, like Linux and macOS specific architecture. So bear that in mind that it can grow in size, and the more code you write, the more hassle that's going to be. All right, so that's were the 3 pain points I wanted to share. And in the last part of my talk, I just wanted to quickly touch upon Kotlin native compilation because it's such a crucial concept that enables the whole thing. So I feel like it deserves just a slide or two. So obviously with Kotlin multiplatform, the way it works is that you write everything in Kotlin, that's fine. But then it gets compiled into so-called intermediate representation, which is an abstraction. It's a set of instructions that are platform independent that capture nicely the gist of your Kotlin code, all the semantics, and allow for optimizations. And then the Kotlin native compiler leverages LLVM, low-level virtual machine, which then takes this abstraction and produces binaries that are targeted for the platform. Which again, this is perhaps a better picture. So it's just broken down how it actually works. And LLVM actually supports a number of architectures, and that's what empowers or makes the Kotlin multiplatform so powerful. Like these tools, thanks to LLVM, thanks to the native compiler, you can still use Kotlin and bring it to many different platforms natively. All right, and I believe seeing is believing. So as a developer, as an application developer, you don't necessarily care about these details, but if you go and generate the Kotlin multiplatform project, don't ever type it from scratch. It would be not very time efficient. There's a generator, you just generate the template, and then you import it into your IDE. And what you find is that the Kotlin native indeed is part of the project, but also ships with a whole host of low-level C libraries that most of them are for macOS, others are for Linux, but you can always add more if you want through Gradle. And basically, basically you can there is this interop with C libraries, which I find awesome. If I switch to my project for a bit, again, there's this interop with C language. So this is just a tiny piece of quote-unquote native code I was forced to write, because what I wanted to achieve here were those command suggestions, and I needed to capture user input as it was being typed, and that's not available out of the box. And after some research, I realized I need to do this platform-dependent approach. So this is still Kotlin, but it interacts with C. This looks a lot like a C function, and indeed it is. If you notice here, there is this even C interop package and platform POSIX package. So similarly, Kotlin having interop with Java, Kotlin Multiplatform is interop with C. Which brings me to the next point, and that's memory management. It's nothing major, but based on my limited knowledge, there's some minimum information you need to digest, and that's memory is not automatically managed for you from the moment you start interacting with the platform libraries. Luckily, there is this DSL memscoped, which does exactly what you would think it does. So whatever memory is allocated inside this block, it will be freed, automatically managed for you. But if you don't use it, you should, whenever you allocate memory, you also are responsible for freeing it up when you don't need it anymore. All right, so that's pretty much wraps it up. That's all I wanted to say about Kotlin Multiplatform. As I said, my knowledge is limited. I just find it interesting, and now there is space for Q&A. Thank you so much.
Maybe I have one question. Why did you decide to use the Kotlin Multiplatform for the Zoom SDK?
It's a good question. Actually, I got some feedback on our last meetup when I first talked about the project more than the technologies. And the question was, why don't you use multi-platform if you're targeting, different platforms? I was thinking web and maybe, mobile apps. So I got this feedback, so I decided to try it out. I almost gave up on the technology some time ago when I was trying it for the first time, and I was underwhelmed. So, but now I got back to it, and I have to admit, it has improved since then.
Thank you.